So Prisma has launched its Postgres offering, which is a very interesting vertical. A lot of things to talk about in this video, and I want to take out time to explain everything which I have seen using Postgres on AWS, Postgres on Neon, Postgres on Supabase, GCP, all of these providers, and where does Prisma's offering stand today. Further, we'll also discuss some of the questions I asked Prisma's team itself and the answers they gave me. So let's start this video first of all by talking a little bit about Prisma. So Prisma is, if you don't know what Prisma is, it's a company that was or is, I would say, is very popular for its ORM, which is Prisma, right? So Prisma is the name of an ORM, basically provides a lot of great syntax to write SQL queries. It also provides a lot of good things out of the box like schema. For example, Prisma schema is something even we use for our own work or for our own backend on Fermion and Codedam, even though we don't use Prisma ORM because the schema is too good. Right? On top of this, Prisma also provides like a bunch of tools here and there like Prisma Accelerate and Prisma Pulse. So these are like sort of like connection poolers like we have discussed in previous videos. PG Bouncer is one of the connection poolers. Prisma Accelerate is also sort of like that, but with like batteries included and globally distributed and all of that, caching and all. Prisma Pulse is also an offering, which is one of the things included in Prisma's suite of Stack now, where you can just subscribe to certain events and you can just get notified, sort of like Redis PubSub. But so far, honestly, in my opinion, the strongest offering they have presented is the Postgres one, because everything else which you would see, it's something which is there, but the problem is that every database already has like its own solution for a specific thing which they are providing, right? For ORM, there are other ORMs which are available in the market. For Studio and Optimize, for example, there are tools like, if you're using AWS Aurora Serverless V2, you already have query analysis for you. For Accelerate, I mean, you can technically go ahead and start your app without Accelerate also, right? So it's not a painkiller, it's sort of a vitamin which you would need. But Postgres is a painkiller because if you don't have a database, then you don't have a company, you don't have a product, you don't have anything. And database is one of the core components of your organization, right? Because if your database goes down, your company goes down, your business stops, you basically die. So this is the release blog of Prisma's Postgres, where in the TLDR, they have just said that we have released a managed Postgres service that gives developers an always-on database with pay-as-you-go pricing for storage and queries. No fixed cost, no cost for compute. I'll come to this because this is an exact question I asked their team also, and the response was interesting. It's like a serverless database but without cold starts and a generous free tier. So this blog post basically goes into 2-3 things. The first of all is like the architecture on how they are hosting it exactly. So what they are doing is that they are putting this on a real bare metal, not on a cloud, right? And they're using something known as these unikernels and micro VMs, right? Which is sort of a way to build an app as a whole thing, including like the kernel it needs, the system level things it needs, and you can just take that whole thing and put it on a bare metal, right? So you get increased performance and a few things out of the box when you do something like this. So you see, it says here that Prisma Postgres comes with connection pooling, caching, real-time subscriptions, and query optimization recommendation out of the box. And all of these products are separate products, right? Which I just showed you over here. So Prisma is putting all of these products on top of Prisma Postgres. The Postgres, by definition, by default, it does not come with all of this. All of these other products are Prisma's offerings. So Prisma Postgres says that it's a new era for serverless Postgres. Our new architecture takes a fundamentally different approach to provisioning the databases compared to existing cloud providers. A serverless database like Aurora Serverless follows a similar model to their counterparts in their serverless compute. Their main promise is to free developers from managing database infra while providing cost-efficient pay-as-you-go pricing model. When using a serverless database, developers don't need to think about provisioning resources like storage or compute as the database autoscales, which is fine, right? For example, if you have a database like this and it's getting a certain number of queries, fundamentally your database is also part of two things. Your database is part of your CPU, which is like the actual logic of the Postgres. How does it retrieve data? How does it use index? How does it query plan? All of that. And then there is a second part of your database, which is the actual storage, like raw storage, right? So your backend itself is a CPU which is like, what we mostly talk about. And then we just say that, okay, your database is the database. But mostly your database consists of these two components. So over here, what they are saying in general, what serverless database is that both of these components are like free from your body. Ideally, I mean, in some cases you have to be constrained about CPU, but in most cases the storage is expanding and contracting based on like how much it is used, how much it is required, and so on. The CPU, however, is the interesting bit, because in some offerings like RDS, if you are using just RDS, you have to go with a predefined CPU. In other cases like Aurora Serverless V2, this can also like increase, decrease, and in case of Neon also, for example, this increases or decreases based on how you want it. Cold start's major drawback of serverless databases. The promise of auto-scaling often means that a database can scale down to 0, that is, it's suspended. This can lead to higher query latencies and poor experience when the database needs to be woken up. While serverless databases have their advantages, cold starts are a major drawback. So I would beg to differ on this point. This is something which they mention like a couple of more times in the blog post, and they like heavily put this as a real pain. It's not really a real pain, and I'll tell you why. Most production applications will never go to sleep, right? So if you have a production application which is receiving traffic, which is like a big application, or it's sort of like, it's receiving some amount of visitors, you would expect that you are getting at least, on average, you're getting at least one visitor or page view or a backend call a minute or a couple of minutes, right? Even if you do this math, you figure out that there are 1,440 visitors, 40 minutes in one day. I'm assuming that if you are operating at any sort of meaningful scale, you are getting more than 1,440 hits. I'm not even talking about unique visitors. I'm just talking about hits, right? So it's not exactly like a one-on-one thing, but what you would realize is that this thing over here is not a major problem. When you grow your product, when you grow your company, when you grow your startup, what you will also have is a lot of background activity going on, some sort of crons, some sort of things which are taking up in background, some events, some webhooks are fired. So all the time your backend would be getting invoked in one way or another, and it will be talking to your database. So cold start is a problem that happens when your database has scaled down to 0. That means this compute has just vanished and just there is storage. And now your backend makes a call, and the provider, whoever it is, Neon or Prisma or whoever, they have to restore this compute back somehow, right? So that is what they're saying, is that in Prisma Postgres, this is completely solved. So it's a millisecond restore, which is great, but I don't see like how this is a huge pain point. Cold starts are a real pain. I don't see like why this is a real pain for production applications. If you're running a very simple dummy application which does basically nothing, it's a side project, then yes, this would be something that would benefit you. But then the stakes are so low that even if you have to wait a few seconds for your application to start, I don't think anyone would mind, because you don't have real traffic, you don't have real people. Yeah, and even if you still need that, you can always put up some sort of cron or something that runs once a minute and just keeps something in your database to keep it up. So cold starts is a problem, but not a major drawback for serverless database, not at all, especially if you are a production company, something like, being used by a few people at least. Serverless database providers can only offer very limited free tiers. Free tiers are essentially essential for developers to explore a database service, build hobby, all of this. Prisma Postgres, a serverless database with a generous free tier and no cold starts. So they say like, it's a generous free tier and no cold start, all of this. But just as a one-on-one comparison, if you look at something like Neon has a 0.5 GB storage, which is available for free. It has up to 2 compute units of auto scaling available, but the number of hours would be limited, I'm assuming. So you can see it's only 190 hours a month. So you can't keep Neon completely, active, right? So you can't just keep it online 24/7, like I mentioned in case of like cold starts. So you will 100% have cold starts if you're on the free plan. And the fact that Prisma's blog used a screenshot from Vercel means that these cold starts are also Neon's problem, because Vercel Postgres is basically Neon. Vercel uses Neon internally and they are just selling it as a Vercel Postgres thing. So that is where they really shine, because if you look at the starter free plan, you would see that in the Postgres itself, they are offering you double the limit, which Neon does. They are offering you something weird, which I'll get to what I mean. So it's 60,000 queries. They are offering like some sort of additional quota, and they are offering you some sort of egress, which is again weird, 1 KB per query, right? So surprisingly, they don't have a concept of compute, which is fundamentally always how databases have worked. For example, Neon offers auto scaling up to 2 vCPU. They just don't show you that, right? That what is your pricing for compute. It's not available on their pricing page. However, on their blog post, I think somewhere they had written 1 vCPU. Okay, maybe not on their pricing page, but I've seen it somewhere in their offering that it's like 1 vCPU offering. Yeah, so if I show you around in the Prisma console, I swear I can't find it now. A few days back when I was trying it out, I'm pretty sure that it mentioned that it is 1 vCPU and 1 GB RAM on the pricing page also and on their data platform also. And now it seems like they have completely removed it. They have completely removed it, guys. I don't know what is the reason, but this is one of the questions which I also asked in the email. So I'll show you that, but they have now removed it. So I don't know what the underlying compute is at all. They are just showing you the storage. Very confident that there used to be a part here where it used to show you 1 vCPU also, which is, you know, the compute they are offering, and they had written a text, if you want more compute, reach out to us, something like that. But now it's not there. Interesting. This model which they have where they are not offering you compute at all is very interesting to me, because it could be a great or it could be a very bad model, and I'll tell you why. But before that, let's just cover this blog post completely. So then they talk a little bit about their Unicraft cloud stack architecture, which is how the whole thing works in their architecture. They don't use any sort of cloud provider, just like Neon relies on AWS and Azure now also. Neon also supports Azure now. For Postgres, Prisma runs on bare metal. So they have rented out servers across the world, and they have, like, you know, they're just doing it the hard way. They're using a concept known as unikernels as micro VMs. With Unicraft and Firecracker, we are seeing Firecracker a lot in these days in the wild. If you remember Vercel's last video, which I covered how Vercel used to build their stuff, they also use Firecracker. And unikernels are famous for providing excellent performance in terms of boot times, throughput, and memory consumption, which is just like a nice optimization which they have for their compute unit, which is the bare metal, right? Now, the advantage here is that the more efficient you can be with your compute, the lower your cost would be, and that means you can offer more free things to people, right? Then they tell about how their binary is like 5 times smaller than the original Postgres image, because thanks to this architecture which they are using, so they are not bundling everything in the operating system and on the kernel level. They're just bundling things which are required because they don't want to run anything else except Postgres. So you can see that it clearly like increases the amount of instances which they are able to run on a single bare metal. Say thanks to Unicraft, a single machine can host thousands of applications, in our case Prisma Postgres, which is the only thing they have to run. So then this is more of a virtualization layer, and then you have like a sort of table which goes into the depth of it. But from a developer point of view, you are interested into only a few things like cold starts, for example, if you are working on a basic project, or the pricing, for example, if you are working on a production ready project, right? And on top of this, because Prisma is going backwards in terms of like they solved the easy problems first, and then they are solving the hardest problem, I would say. The reason I said like this makes so much sense as an offering is because managed Postgres is an extremely hard problem, especially when you are doing it for many people, right? It's not like an open source thing, it's like a managed service. So what they did is that they built all the nice products which they have. I mean, I don't fully agree with the ORM thing. I'm sure like they have changed it. I've heard about Prisma improving their performance a lot with ORM, but the last time we tried it, it was an absolute disaster in terms of performance and how it internally was architected. But I think they have changed a lot of things in the last 1.5 years. So I don't know. But anyway, even except ORM, like they have a bunch of other things which they have already created. Now they're creating the hardest problem. They're solving the hardest problem now with Postgres. And then because they already have all of these toolings which other providers like Neon or other people don't have, they have sort of an edge over here, right? Many people use Neon with Prisma ORM, right? Many people use AWS RDS with Prisma ORM. So they already have their customers who are potential buyers. All they have to do is make this offering so good and so irresistible that they think about migrating their existing setup to this. And Prisma, by the way, is not a small thing. If you go on Prisma NPM and if you check out their downloads, you have more than 2 million downloads in a week, which is crazy. This is not a small number at all. So the customer base which they can potentially tap into with their services, I would say, is probably far larger than Neon or, you know, any sort of independent service which is coming up. I think because they have very popular open source project. and everyone knows about Prisma. So anyway, that's basically it for the blog post point of view, but this leaves a lot more questions which were unanswered. So I had to reach out to one of their team members on Twitter, and they connected me with somebody else, and then we got to a few questions. So let's talk about my questions which I asked, right? So I'll go through the feedback, I'll go through the email as well. So first of all, they just said that, we are currently in the process of refining our pricing structure to make it straightforward and cost effective as possible. While I don't have the exact details to share just yet, I would be more than happy to keep you updated. So the pricing part was something which I asked very clearly, because I remember seeing, now they have removed it, but I remember seeing there was a 1V CPU over here somewhere in the pricing or in the blog post or somewhere. So that was not clear to me. Plus storage also, 1 GB storage is extremely low. If you have worked with Postgres, you know that indexes take up a huge amount of storage, right? So if you have basic indexes also, you will just exceed the storage, and basic data set also, you will exceed the storage very quickly. So this is not for production at all right now, because even if you see enterprise plan, they have still written 1 GB storage. So it's a very early product. It's meant for free usage right now. It's meant for you to try out things and see how it's working, what's the feel like, and so on. Right now, Prisma Postgres is running in early access, which is fair enough and can be taken for a spin for a small non-mission critical projects. It's not yet recommended for production workloads, which is fair. Now, some remarks from your questions. Is it possible to use raw Postgres without Prisma Accelerate on top of it? If yes, then how would the cost look like? So see, the reason I asked this is because if you go ahead and create if you create this database, for example, I think I lost the connection string. Yeah, here you go. So this sort of thing which you have. First of all, this is, Prisma plus Postgres, and this has a structure of accelerate.prisma.net and then an API key, which is a JWT token, right? It looks like a JWT token. This is not a standard format at all for a Postgres string, right? Usually you will have just Postgres over here, not Prisma plus Postgres. And then you'll have a username, password, and then the host, and then the database. The string here is very weird because I've never seen something like this. Now this is a JWT string. I will rotate my credentials so you don't have to worry about that after this video. And if you look into under the hood of what this JWT is carrying, it's carrying some information which is API key, tenant ID, and internal secret, right? I'll still just blur this just in case. I don't know how many of these values are even rotatable. So this JWT just contains this, and based on this itself, it somehow is able to route internally on what database it needs to be. Plus, what I see over here is that this token which you have, it doesn't has an expiry date, which is weird because now you have a JWT token which is valid forever, which is interesting because, I mean, you can't really technically put expiry date to a JWT, but why include JWT in the first place? Why not just give API keys directly, right? So I'm not exactly sure about that. But the dashboard right now feels extremely slow. I don't know. It's not my internet connection for sure, but it seems like everything is taking at least 3 to 5 seconds, and in terms of loading and in terms of setting up. But anyway, so the question I asked was that how do I connect this directly if I have to use my software, which is like, Postico or some sort of visualizer, which needs proper authentication, because the string which I showed you right now, it's not a proper authentication at all. This is not how clients usually connect, right? But Prisma is able to handle this. So I'm sure like their own driver works, but how do I work with my local software to see the database? So it doesn't work that way. That's what they said. Direct access via TCP is not yet possible, but this will come soon. So they mentioned like one of the limitations, temporary limitations, no automated backups. So they don't have backups right now. They will obviously have to add it. There is no direct TCP connection. You just have to use Prisma ORM. You have to use Prisma Studio if you want to visually explore and edit your data. Other databases GUI like Postigo. Okay, so they have already mentioned it. But Table Plus are not yet supported, which is bad because I need to use them in a lot of cases when we are doing some sort of complex operation, or if I just need familiarity with the tool. Also, you have to use Prisma ORM with the Accelerate client only to interact with your application. Other ORMs and DB libraries like TypeORM, SQLize, or Next are not supported at all. And plus, same resource allocation exists regardless of your pricing plan, which is again 1 GB maximum storage and 16 is the version of Postgres. I can bet that there was a 1V CPU here somewhere also, but now it's not there. Then I asked the other question, how would the storage and usage cost looks like? Right now, every plan is limited to 1 1 GB RAM and 2 vCPU. Okay, so they had this, not 1 vCPU. That is why I wrote in the email, because I read this somewhere on their pricing and something. And 1 GB storage, which is very limiting for production use cases. Is there a pricing plan available right now for more storage and compute? This is something I asked, right? And I asked it further that the blog post mentions no compute in the first line. Does that mean 1 GB RAM, 2 vCPU can be scaled up without any cost? It seems wrong, I guess. Is the compute truly scalable in a way without downtime? Can we go from 2 vCPU to 16 vCPU without downtime? Since you use bare metal server compute and SSDs, I wanted to understand, is the compute and storage truly separated here like neon? To which they answered me that unlike traditional database providers, Prisma Postgres charges for query volume, not compute, which is what I saw in their pricing now. Because earlier, I'm not sure if they had a monthly queries earlier also. In the Postgres section, I'm sure they had it in the accelerated section. But in Postgres, they had a 1 vCPU and 2 GB RAM thing. 1 GB RAM and 2 vCPU. I just keep on confusing the numbers. But they mentioned that Prisma Postgres charges for query volume, not compute. We are aware that this is a mental shift, but I do believe that this ultimately presents a more intuitive model for developers to think about database costs. Our goal is for you to only think about queries. We'll take care of everything else to make sure those queries can run. You shouldn't need to worry about compute, scaling, downtime, etc. Please let me know if I can do anything else for you. So this is like a closing statement. I didn't have to read that in the video, but anyway. So my biggest problem with this is that this approach feels wrong to me. That when you are charging on query, what happens to the pricing? Because not every query is same. Over here, what you are saying is that select star from, not even this, select ID from my table 1, where ID is equal to 1337, right? And then you have another ID where ID is equal to 1337 also, another table. Now, looking at these queries, looking at both of these queries, can you tell me which query is computationally expensive? You can't, because it depends on so many things. It depends on what is the size of this table and this table. It depends on what indexes are there and indexes in this table. It depends on like how busy the Postgres engine is in general. What is the CPU utilization right now at the time when you run this query? Imagine if this query is for a table which has 5 records, which has 1 record. Let's just go down that way, right? It just has 1 record and which has an ID of 1337, right? And there is an index also on this. I don't know, like why would you even need an index for a single record? But let's say you have. Then let's say you have this query over here, which has a billion rows with no indexes. So you have to do a full table scan for this. Now, obviously, this would take so much more compute than this query. But according to Postgres, because their pricing includes a query-based pricing and includes monthly egress, because at the end you are just getting 1 record over here and over here. So this egress cost is same. This addition, what else? Query response size is same. Query duration is something that is, I don't know, like if this would be a chargeable component, because if it is chargeable, then you are indirectly charging for compute time, right? Because your query duration is sort of a function of a compute time. I don't know if this is chargeable or not yet, but I don't know if you can feel me, but over here, this feels like a wrong mental model, right? Because as a developer myself, I'm not fully sure on what's happening now when I'm getting charged, because Prisma for sure is paying for compute, right? Prisma is paying for compute, but they're charging you for queries, and their pricing model is also 60,000 queries and then $18 per million queries. I think this is sort of a high number, right? Because I don't know the exact count with us, with Fermion and CodeDam what we have, but I'm pretty sure that we are doing at least 2 to 5 million page views at least a month, and for every page view we are on average doing maybe 2 to 3 queries minimum. So we are doing north of like 10 million queries a month easily on our database, and a lot of these queries are like basic queries. So we are easily gonna pay, at least on the free plan, $180 a month, here $80 or $90 a month, and then so on. And plus, because now queries like this query is similar to price in this query, I mean, it's just sort of like, you know, it just sort of feels weird. It's right, it's a mental model shift. I'm not sure if I agree with this mental model shift, because it doesn't help me optimize my code base for performance. Sure, I can reduce my query duration time, but you know, my queries are taking or costing the same thing, then I would probably not spend a lot of time optimizing it. And I'm not even sure like if you can really optimize it with the Prisma ORM which you have, right? Because it's like very restrictive in terms of how you are writing SQL. It's not like real SQL, so you will not be able to see what the final query is. Like that was one of my complaints also with Prisma when we figured out that it's using in-memory join instead of like actual SQL join. I don't know what they do now, but that was the use case. That was the case earlier. But yeah, this is an interesting approach. I don't know how this would work out or how popular this would become. If I were building this, I would probably keep it on compute and egress only, like other providers. But because you're doing it on bare metal, because you're doing it everything on your own, you have an advantage where the costs are controlled by you. One of the biggest problems with Neon or any other providers is that they are limited with their contract with AWS, right? So whatever AWS is charging them, they have to pay at least that, so they will at least charge you that much money. With bare metal, you have that advantage where you can drop the cost even further. And I mean, don't get me wrong that this model doesn't work. It's basically what most companies do. Most companies, what they do is that nobody like always just keeps on charging you on compute and, storage. Otherwise, it won't make any sense. Imagine like Gmail is charging you for compute hours for using gmail.com. It doesn't do that. If you're on a work plan, it'll charge you per user and it'll sort of assume that you will, more or less they'll make money at the end. But with services which are so low on the stack, like they are very close to developers and your business and they're very core to your service, I don't think these abstractions would really make a lot of sense, but I might be wrong. Time will tell. So that's basically it for this video. Do tell me in the comments what you think about this new offering. Are you gonna use it or not? Hopefully this helped you clear out what are some use cases, what are some drawbacks right now, and what are some advantages of using this. Don't forget to like and subscribe the video. Thank you so much for watching, and I will see you in the next one really soon.